Welcome back to lesson 3, week 1 math, and this is going to be a really quick video as well. We'll do Thursday's Mathmentals, and then I'm going to give you time to go back into Edge Studio and do some of those activities. I was going to show you a video, but I think go back in and do some of those interactive math activities on the page, and I'll show you where they are. So on the math page, when you click on Mathmentals 1, you come to this page, and as you go through down the bottom, you can see lots of activities that you can go on and do. Okay, all right, Mathmentals for Thursday. And once again, head up your page, week 1, Thursday, the 23rd of April, 2020, and Mathmental. I'll try and clean this board off again. Okay, I should have done that in between, but anyway, here we are now. Okay, so the first one is time. So have a look at the time on the wall. Remember, the small hand's the hour hand, and whatever number it goes past is the hour, and the middle hand is the digital hand. The long hand is the minute hand, sorry, and that tells you. I just downloaded this. So if we look at the time now, the hour hand's just gone past 7, so that's 7, and then the minute hand gone past 5, 10, 15, 20, 25. It's not quite on 30 yet, it's 1 off, so that's 29. And there's the second hand in time to show you an Australian Eastern Standard Time. Okay. And it's AM, of course, because it's in the morning. Midnight to midday, after midnight to midday is AM, ante-meridian. After midday to midnight is PM, post-meridian. Okay, multiplying fractions. Please make sure your name's at the top as well. 3/4 plus 3/4. And of course, we leave the denominators the same. So 3 plus 3 is 6 over 4. We can't leave it like that because that's an improper fraction. So we need to simplify it. And the way we do that, because the bottom numbers always means divide, remember, is we divide how many 4s go into 6, and there's 1 4 and 6 with how many left over? 2 over 4, but we still can make that even smaller, so we say 1, and there's 1, 2 and 2, so that's 1/2. Okay, number 3, how many diagonals can be drawn in a pentagon? That's 5 sides. So we've got, and they don't have to be symmetrical, okay? They're just diagonal lines. I can't see any more. I might Google it just to make sure. They're only how many diagonal lines I can see. Let's have a look. Good old Google, where would we be without it? So, how many diagonal lines can we draw on a pentagon? Get my face out of the way. Oh, here we go. So not only have they got this one and this one, but up the top where the point is, see, I should have made mine bigger. They've got the point going down to the corner and down to the corner. So that's 1, 2, 3, 4, and then they've got this corner going back up, 5. And this one going back up as well. So then it's the reverse one. So 6. Oh, well, there we go. Now we've got question 4. 2.5 divided by 5. Now this is a tricky one because when you look at 2.5, it is way smaller than 5. So how are we going to fit 5 within 2.5? The way that we do it is we immediately treat 2.5 like it is a decimal, because there are no 5s in 0, are there? So we say to ourselves, well, there's no 5s in 0, so straight away, there's no 5s in 2.5, so straight away that's a 0. So we put 0 there where the 1 should be, because no 5s fit into 2.5, and we move 2.5 on the other side of the decimal. So then what we can say is how many 5s in 25? And the answer is 5. 5, 10, 15, 20, 25. But we can't call it a whole number because we know there's 0. 0 5s fit in 2.5, so we just call it 0.5. Okay, the next one, what is the diameter of a circle if the radius is 6 centimetres? So remember, diameter is from one side to the other, and that is 6 centimetres. So the radius is half the circle, half the diameter. So what would it be? It would be 3 centimetres. Now this one, it's really easy to go, oh, it's so impossible to work out, but it's a bit of a tricky one. So $80 shared with 16 people. So what's an easy way to do that? Well, first of all, you'd halve how many people. So you'd say, to make it a friendlier equation to do. So instead of saying share with $80 with 16 people, you say share $80 with 8 people. Now straight away, you know you've halved it. How many 8s in 80? 10. So now we have to halve it again because there's actually 16. So 8 people with $80, that's 10. Now we're going to halve that again, and the answer is 5. So if you share $80 with 16 people, they get $5 each. Right, this one here, a bit of BODMAS. So we do the brackets first. Which bracket should we do? The division. 3 plus 4, oh, I thought that was a division then. 3 plus 4 is 7, and 3 plus 8 is 8. So 8 times 7, and you can look that up and find the answer. Okay, Roman numerals, DC, what does that mean? Well, we learned the other day that C stands for century, so that's 100. And I put up a little screen on Google to show you. So it's DC. So D in Roman numerals is 500, and a C is 100, so it's 600 altogether. And just have a quick look at your Roman numerals while you're here. You can write them down if you want. Okay, and going back into our mental maths. So we're now up to round 3 and 3/7 is to the nearest whole number. So if we've got 3 wholes and we've got 3/7, which means that we have cut something or sliced something into 7 parts. And I'm going to do a rectangle because it's pretty hard to slice up a circle into 7 parts. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 5, 6, and one more, 7. Okay, and how many have we coloured in? We've coloured in 3. So 1, 2, 3. Is that nearly half? No. So we've got to round it to the nearest whole number, so we round it back to 3. Because if there was 4/7 colour in, then we could round it up, because that would be over half. Okay, the abbreviation of Eastern Standard Time, or EST stands for what abbreviation? I just told you the answer, Eastern Standard Time, and I've got a little screen open for this as well. So Eastern Standard Time means that depending on where you are in the world, you will be in a different time zone. So if we look at Australia, this side of Australia is on Eastern Standard Time, which means that we are using this time. And the other side of Australia, and the world for that matter, so every everything on this part of the world is on Eastern Standard Time, and everything on this part of the world is on another time. And I think if I go back one screen, it should have that. No, it's not going to show me. I'll see if I can very, very quickly get it up. No, just brought up the same one. But so everything on this side of the world is going to be on Eastern Standard Time, which is this time, and everything else is going to be on a different time. So that's what EST stands for. Okay, where are we up to? Okay, how many angles in a square? And of course, there's an angle on each corner of a square, and what kind of angle is it called? It's called a right angle, an L shape. I'm not going to draw that because I'm sure you know what I'm talking about. So what's the pattern here? 60, 600, 6,000. So they're adding a 0 each time to take you up to the next value point. So if we add another 0, the answer is going to be 60,000. I'll make my square bigger again. 60,000 because we've added another 0. Yep. There we are. Okay, 8,000 plus 9,000, and once again, this is just knowing the strategy that the same amount of zeros, same place value. All we've got to do is add these two and add those zeros on. So do the answer. So we can even call this a friendly number and round it up and say 10. So 10 plus 8 is 18, and then we can take 1 away to make it 17 and add the zeros in, so 17,000. A van has a tar, I'm probably saying that incorrectly, of 1,500 kilograms and an aggregated of 2,500. So this is the van just on its own. This is the van or ute loaded up with something in the back. That's why it's heavier. So what mass can it carry? So obviously we need to take the smaller number, which is the actual weight of the ute, away from the bigger number, which is how much the ute is when it's loaded. So we say 2,500 kilograms, which is the ute loaded up. Take away 1,500, which is just the ute by itself with no load. 0 take away 0, 0, 0. 5 take away 5 is 0. So it has a weight capacity, don't forget to write it in your answer, of 1,000 kilograms. That's how much it can take in the back, which is a lot. Okay, a pentagon has how many sides? And I drew that terrible pentagon before. So a pentagon has got the triangular roof, slightly sloping sides, and then the bottom. So 1, 2, 3, 4, 5. If you ride your bike 3 kilometres in 10 minutes, how many kilometres in 1 hour? Now, because it's telling us 3 kilometres in 10 minutes, we have to use the same conversion. So we've got to convert 1 hour to minutes. So then that becomes 60 minutes. So if we rode 3 kilometres in 10 minutes, how far are we going to ride in 60? And we say 3 times 6, because there's 10 minute lots in 60, so 6 times 3, and the answer is 18 kilometres. Okay, next one is 15 take away 9. I'll let you work that out. Really easy way is you can round that up to 10 and say as a friendly number and say that that's 5 and then add one more on, so that's 6. Write 1,100,000 as a numeral. So 1,100,000 as a numeral. 20 take away $3.25. So you can use your friendly math strategies, but if you want to do it as a vertical subtraction, which is really good practice, $20, and we put our cents in as well, because what we're taking away here has cents in it. Put our line underneath. 0 take away 5, we can't do. 0 take away 2, we can't do. 0 take away 3, we can't do. So we go to our last number, make that a 1. Pop the 1 on there, but we take it off because we need to borrow it. Pop the 1 on there, but we take it off because we need to borrow it, and put it on here. Now we can do the whole sum. 10 take away 5 is 5. 9 take away 2 is 7. 9 take away 3 is 6. And there's the 1. So the answer is $16.75. And of course, some of us would have done that in our heads, where we just would have taken the $3 off 20 for 17 and known that $1 take away 25 cents is 75. And there's our answer there. Okay, and we're already up to our last question. A 5 centimetre block of wood displaces 5 mils of water. Now, these questions aren't as complicated as what you think, because you visualise this 5 centimetre cubed block sitting on this amount of water, displacing it, which means spreading it to the same distance as what this 5 centimetre cube block is. So if we then get a 50 centimetre cube block and we put it into water and it flattens down on the water surface, how much water is it going to displace? Well, following this same principle up the top, the answer of course is 50 mils. Right, we got through that really quickly, so I'm going to finish up there, but if you want to use the rest of your time to go in and do some of these interactives in Ed Studio, please go ahead and do that, or even catch up from some of your work from the previous days. All right, that's it for today. Excellent, thank you, and I'll see you tomorrow for dictation, going over our homework, and a reading of Magnus Chase, as well as a look at science. Had a great week. You guys are working really well. Keep sending your work in. Thanks.